Welcome back. Organized counting, so n factorial. When you're going to get into some kind of counting at some point, you will run into this particular symbol. So n, and then it's actually the exclamation mark, which stands for factorial, or at least that's how it's read. Now, what does this mean in terms of math? So it's not very complicated, and it's a nice way to shorten multiplication between numerous integers. So for example, n factorial is really defined as, so n is some integer that we have, and I guess you can assume that it's actually maybe some natural number, and what it means is you're going to be multiplying, okay, so this would be n multiplied by, and this is n minus 1, so you reduce n by 1, you multiply it by n minus 2, and you keep doing this multiplication until basically you get to the 1. So that's what n factorial means. So if it was, let's say, 5 factorial, it would mean 5 multiplied by 4, multiplied by 3, multiplied by 2, then multiplied by 1. And as you can see it, if you do the multiplication, so it's not very complicated, and you might say, well, why do I need to write this factorial or this exclamation mark in there? Why can't I just write it 5 times 4 times 3 times 2 times 1? And I would agree with you, okay? So for the smaller ones, it works, but if someone comes along and then says, you want to be able to find out, let's say, 56 factorial, then writing this out now becomes a little bit of a pain because you have to keep doing this, all right, until eventually, you'll get to 2 times 1. And clearly that's a lot of integers that we would have to be able to write out. So this shorthand is kind of useful. Now, where is it used? It is used in counting, and I'll show you some examples. And it's typically trying to utilize when you do have n, say, characters or n items, and you want to be able to organize them. And you can ask the question, okay, so in how many ways can I organize, n numbers or n items, okay, or n characters or n speeches or photographs? So I'll show you some of those examples where you can use this. Now, the mathematics behind this, you can certainly do something like this, and this one, we can calculate in our head. So 5 times 4, right, is 20, times 3 is 60, times 2 is 120, and then times 1 would still be 120. So that one is fine. But if you get into the bigger ones, well, you certainly don't want to be just multiplying this out. Even if you did have a calculator, you would take you quite a bit of time. Now, luckily, most scientific calculators, graphing calculators, and now various application tools actually do have this symbol included so that you don't have to enter all the multiplications in. Now, please do be careful because depending on your calculator, it might have an upper bound of how big of a factorial it can compute. So sometimes, some calculators can't really go any further than like 70 factorial or even maybe less, but some of them can actually go pretty high. So here is my app that I use, okay, so my calculator. And I do see this factorial, so you see that x factorial there, so x just stands for a number. So for instance, if I wanted to write 5 factorial, okay, so notice I enter the 5 and then the factorial, and then I hit equal, and it'll give me the 120. So it does the multiplication for me. Now, when it's bigger, notice it's going to start getting pretty large, right? Because if we had 6 factorial, right, 7 factorial, 8 factorial. Remember, you're multiplying these things through. So if I take 56 factorial, it's going to be huge. Notice in this representation, so they actually had to put it in scientific notation because that's how big it is. So 7.1099, okay, and it keeps going, multiplied by 10 to the power of 74. So this is in scientific notation because it's so enormous. Right? So as these things get bigger, the result becomes bigger and bigger and bigger. But the idea behind factorial, that exclamation mark, is kind of useful to be able to know. So you will run into maybe even some kind of manipulations without any word problems in the beginning. So your teachers might ask you something a little bit simpler to calculate. So, they might just see, can you compute these things out? So for instance, you might run into some examples where they're just asking you, please calculate, let's say 7 factorial multiplied by, let's say maybe 3 factorial, right? So if you wanted to do this, you can do that. We don't typically write necessarily the multiplication in between here, like so. We typically will skip it, right? So it would be looking something like this, and it would literally mean just multiplication of the 2. So if you did have your calculator, you could have just then said, okay, so 7 factorial. I would still encourage you to put multiplication, okay, on your calculator, and then 3 factorial, okay, is equal to, and then we would get our answer within here. So that's 30,240. So that's multiplication of these 2. Now, I don't know, if you put in 7 factorial, and then without the multiplication, you put 3 factorial, okay? So you'll notice that you might get something like this, which is a syntax error, because the calculator may not know. So we may write it like this, but still put in that multiplication in there just in case. It will depend on which calculators you're using. Now, sometimes what happens, because these things can get rather large, as you saw with the 56 factorial, now, if it keeps going, your calculator might not even be able to calculate. So what can happen instead, maybe you get something like this, where the numbers are rather huge, so 89 factorial, but then you have a division, and let's say maybe the division is something, let's say 82 factorial at the bottom. Okay, so your calculator may not be able to do 89 factorial, right? And then divide it by 82 factorial and give you an answer. It might just say, I can't do it. It's too big. So in these instances where you do have kind of larger ones and you do have division, then I do encourage you to try to go back and think, what did the actual definition of factorial mean? And you will notice that if we would have written this out, so this would have been 89 multiplied by 88 multiplied by 87, right? 86, 85, 84, 83, and then it's going to be 82, and it keeps going, right? However, notice that in the denominator, so here, the 82 factorial would have started at 82 times 81 times 80, and so on. And notice that these, okay, will actually cancel because you also have them on top, right? Now, I didn't write them because I ran out of space, but these will simply cancel each other off, okay? So all you have is just the multiplication, okay, of these. Now, it's still quite a few in this particular case, but if your calculator can't handle the 89 factorial and then divide it by 82 factorial, you can always revert to the actual meaning of the factorial, which is the multiplication of those integers, and then just do them directly. So here, if I was stuck, I could have said, sure, still take me a little bit, but I can certainly enter these in and then find out what my answer would have been. So 84 and then times 83, and all the other ones canceled. And then I can do that. It's still a relatively big number, as you can see, but at least I could do it. Okay, so I just wanted to point that out to you. And so here is another one, maybe the last one. Okay, so for here, so if you were running in, and let's say you had 29 factorial divided by, and let's say it was 27 factorial, you shouldn't necessarily even reach for that factorial button, because here you would have known that, oh, this is just going to be 29 multiplied by 28. Because the 27 factorial will cancel, right? Because here would have been 27 times 26 times so on. So these things would have just canceled each other off. and you don't have to necessarily worry about them. So this is just simply 29 multiplied by 28. I'll leave the multiplication for you, but I just wanted to show you. So now, where is this applied? Well, you will see it actually quite often if you are going to do some kind of a probability or counting course, data management. So you're going to run into this factorial because it is part of certain definitions. But in the earlier parts, the typical questions that are asked are something like this. So I've prepared a few questions for you, and I'll try to show you how we can utilize these factorials to solve. So here is an example, and it says if you have 5 different animal photos, then in how many, different ways could you hang them in a horizontal line? So if you think about this, so we have 5 photos. So 1, 2, 3, 4, 5. So they're different photos, right, of different animals that we have. And now I wanted to be able to figure out, okay, so in how many different ways could I possibly hang these things up, right? So, you can swap the orders, maybe you like a cat, maybe you like a dog, whatever the animals were. And now if I want to know the total number, in here, sure, I can start manipulating and, drawing this out and go, okay, this is one possibility, here's another possibility, and so on. But it's much easier if you think back of the organized counting, and you can also think back of that multiplicative, counting principle. I'll put up a link up above that if you didn't watch it. And you'll see that it will tie into this factorial. So if we have 5 of these photos, then remember that what we did with the organized counting, we said, okay, so in how many different ways can I order these things up? Well, in the first spot, if I would take, I have 5 total pictures, right? So 5 different animals. So I would start with 5. And now I'll go to my second stage, right, in my counting. Well, and how many different photos do I have remaining? Well, I have now 4 possibilities that I could put in here. And then again, I move over, and then I would have 3 possibilities remaining. And then again, 2 possibilities remaining, and finally only 1 left. And what did we do with these? Well, this was just indeed the multiplicative principle. So we would just multiply these through, and in this case, we would have had 120 different types, of organizations of these animal photos. But if you look at this is nothing else but simply 5 factorial. So if you are given a certain number of items, and from all of those items, you are wondering, in how many different ways can you order them? Now, the assumption is that they are different, all right? So what you do, instead of going back to that counting principle for multiplication, you can literally utilize the factorial. So in those cases, the answer always is going to be n factorial. So if we had 7 different animals, the answer would have been 7 factorial, right? If we had 10 different animals, it would have been 10 factorial. So that's where we like to use this in the counting, in organized counting, when we are given a certain number of different items and we want to see in how many different ways can we organize them. So, for example, if you had a classroom, let's say of, so it's a smaller classroom, maybe of 10 students, and those particular students had to give some kind of a speech. And you were wondering, in how many different possibilities can we organize these students? So like who will be giving the speeches? Then the answer is 10 factorial. That's what you would have. Here's another example. So this one's a little bit different, and it utilizes, my site, and the mission, so 1M journey. So it says, in how many different ways can you organize the characters in the set? So I'll give you those characters, and basically it spells out 1M journey. So this 1MJOURNEY, they're different characters. So how many of them do I have in here? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So as I said, if I wanted to find out in how many different ways can I organize them, right, let's say in a row, instead of going, okay, well, I have 9 of them, so that means on the first choice I'll have 9. Okay, on the second choice I'll have 8, right? On the third choice I'll have 7, and so on. I can literally just say the answer is 9 factorial. And by the way, even when you are doing this, very often they'll just leave the answer like this. They will not necessarily give how many, because they understand what 9 factorial mean in terms of mathematics, statistics, probability. So if you wanted to know exactly what it was, sure, we can punch it in or do the multiplication. And you'll notice that, oh boy, we can order this in quite many ways, right? If we had that. So that's another example that you could see. I want to give you, some variations of this because it does happen. Now, what if the characters, so these characters, 1, M, and J, must be together, right? So not necessarily in order together, but they must be grouped into this 3. So, it could be 1MJ, okay, or it could be M1J, so that they're all still together, but they're grouped like this, okay, and then maybe it's, J1M, and so on. Now, what if we have that? Then how many possibilities are there now if we took this particular set? So there are still other ones, right? There's OURNEY. So between those, we have 1, 2, 3, 4, 5, 6. Okay, so I have 6 still different ones. So 1, 2, 3, 4, 5, 6. And then I have this grouping 1, 2, 3 that has to be together, right? But it doesn't tell me that it has to be together in the front. It could be somewhere in the middle, right? Or at the end. So how would I count something like this? Because it's not now 9 factorial anymore, because these guys have to be together. So the way to approach this is you can ask yourself first, okay, so since these have to be grouped together, make this one group. So this is one group. And then where will it fall? Okay, well here I still have 6 other possibilities. So instead of having 9 possibilities in total, now I really just have 7 total, which is 1 plus the 6, because those 3 have to be together. Okay, so how can I arrange this? This is going to be 7 factorial. But please also don't forget that inside of here, I can change their order as well. So they can be together, but I can now change it. So inside of that group, in how many different ways can I arrange them? Well, there are 3 of them. So it's going to be 3 factorial, 3 different ways, which is 3 times 2 times 1, which is 6. So my final answer is going to be 7 factorial multiplied by 3 factorial, because that's how I can still arrange that particular group, right? So now I can obtain whatever this answer is. And, you can punch that into the calculator to obtain it. So that's another example for you to think about. If you have questions, you can put them up in the chat, in the comments there. So here is another one, okay, that I have for you. Okay, so let's make it the last one of this video. So what if the characters 1MJ had to be separated by at least one other character? Now we want to count all the possibilities now. Okay, so this one, typically students will have an issue with. They won't know, because what this is saying is that, okay, so I have these 9 characters, right? 3, 4, 5, 6, 7, 8, and 9. And it's telling me that these, okay, characters had to be separated. So we have to separate them somehow, all right, by at least one other character. So I have to fit them in somehow so they're separated by at least one. So how could that possibly happen? Well, I mean, I could have, for instance, 1 in here. So being separated by at least 1. So M would have to be here. So it can't be side by side. All right. And then J could be possibly here. Or, you know, I could have another possibility, maybe 1, right? Maybe I'm separating it by 2. And then maybe M is here. And then this is maybe separated by 3. So I have something like this. So this will work. You know, this will work. But now imagine trying to figure this out. You know, how many different ways. It's going to be super problematic to do it. So there is kind of an indirect way in terms of counting. So let's think about that, because it is very helpful once we get into probabilities later on. So in order to count this, what I recommend is, okay, take the total number of possibilities. So we would take the total number. What is the total number of possibilities? No matter if they're separated or not, if they're together or not, or whatever that may be. So it is total number. Now we know what that is, because that's 9 factorial. Okay? And now, if I wanted to count that they're separated by at least 1, that's hard. But what I know is that if I have the total, do the opposite. So think about, what if they are grouped together, right? What if they start to be grouped together in some particular way? Okay? So in that sense, you know, if I start to group them together, you know, then you would create again a grouping of 3. Okay? So now they're not separated by at least 1 character. So that certainly will happen. Okay? And if you do that right there, then I can subtract it. So when they are grouped together, I can subtract, okay, when grouped. Okay, when there is no, okay, characters in between. All right? So that can happen. So instead of counting this up, that you have at least 1 character in between some of them, you know, so I mean, that would have been difficult. You know, you could have then came back and said, all right, I mean, how many of these possibilities? I guess, you know, this could have been a possibility, and so on, right? There is a space in between here. So if you do this, now we have already counted this actually in the previous one when they were grouped together. So this was 7 factorial times 3 factorial. This would have been minus 7 factorial times 3 factorial. That's when they are grouped together, how many possibilities. And here is the total number. So when you subtract, you will know. Okay, so that is an indirect way of being able to try to solve these. So this one is kind of hard, right? And of course, it will depend on the wording. So my wording within here, okay, if it was on a test, okay, or something like that, it had to be a little bit more clear. But here I wanted to talk through those possibilities with you, okay? So that is the factorial, okay, and where we can utilize in terms of some organized counting. Okay, so thanks for watching, and we'll see you in a future video. Bye, everybody.